you can die because of it. The reason is that your body is made up of acid, because DNA, if you remember, deoxyribonucleic acid, name is, it is in the name acid, and yeah, if you drink bases and put it in your stomach, it's not going to be a good thing. So folks, never ever drink like bases in the sense, things like this, okay, alkalis especially, because they're very potent. The pH levels are 12 to 14. They're really dangerous. Okay, great. So okay, Radha, you're raising a hand. Go ahead.
Bhaiya, what are the examples of alkalis?
NaOH, then CaOH thrice. We'll get to it, rather, okay, when I first explain it. Okay, so folks, alkalis. So if a base, I have a base is nothing but OH minus ions. Okay, if I have a base and it is soluble in water, what is soluble? Soluble means it dissolves. Okay, dissolves. So if you ever put sugar in water and you just stir it, after some time you can't see the sugar crystals, right? Why? Because it dissolves in water. So that means being soluble. It is called an alkali. So if a base is soluble in water, it is called an alkali. But so you might be saying, so Bhaiya, why do we need to know alkalis? Like all bases, they, if you put in water, they get OH minus ions, right? So yeah, there's a basic difference between both of them. Alkalis and bases, nothing but. Now alkali, it is a soluble base and it produces hydroxide ions. So we call it an alkali. So alkali is nothing but a base which dissolves in water. A base which dissolves in water. Now on this planet, there are certain other bases which have the OH minus hydroxide ion, but they cannot dissolve in water completely. Okay. So there are certain bases. Now remember this, certain bases which are on Earth, but they can't dissolve in water. But they are still bases. All right, because of their chemical properties. So, and that's actually a pretty different topic for another day, but you just have to remember is that there are certain bases on Earth, they don't dissolve in water, and there are certain bases which do dissolve in water. So the bases which do dissolve in water are known as alkalis. It's just another word to describe it, okay? So this is nothing but what alkali means. And NaOH is actually one of the biggest used alkali in industry, in the chemical industry. In India, we use this sodium hydroxide a lot because it is abundantly available and easier to make. It's very easy to make. So sodium hydroxide is an alkali because it dissolves in water to produce hydroxide ions. So if you remember Arrhenius' theory of acid bases, he said that if you dissolve anything, get OH minus ions, that is a base. So basically NaOH, aqueous, you put it in water. So I can write water over here, water. And what does it do? If you put a alkali or a base in water, folks, what does happen? Like, what is the process called? Because I have to write it on the arrow. Can anyone just come off mute and tell me what the process is called? There's a name for it.
Can I be here?
Go ahead, Radha.
Dissociation.
Yeah, absolutely. So dissociation. So NaOH, if you throw it in water, basically we dissociate it. Dissociation is nothing but distribution. So basically we have Na and OH, you put it in water, water gets in between and Na and OH split. So that is nothing but dissociation. So we basically get is nothing but NaOH aqueous solution, you put it in water. It is aqueous, so it is in the chemical reaction. You get Na plus, which is aqueous, plus OH minus, which is again aqueous. Okay. So this is nothing but alkalis. Folks, just remember, keep it in mind that we have alkalis, which are bases which are soluble in water. And we have normal bases which are insoluble in water. They cannot be dissolved. So basically we have base, okay, base, let's say base. One is soluble in water. Soluble means which dissolve. And another is insoluble, which doesn't dissolve, okay. So basically which dissolves is what we gave another name for it, which is nothing but alkali, okay. So all alkalis are bases, but not all bases are alkalis. Now think about this, okay. I'm going to put this in the chat box actually. There's something to think about. And you can, just so basically all alkalis are bases, but all bases aren't alkalis. Okay. It's a conundrum basically. So yeah, all alkalis are bases, all bases are not alkalis. Why? Is because not all bases dissolve in water. So you have to keep that in mind. All right. So we go to the next step now of our lecture. So we started with what are alkalis, but now we have to know the difference between base and alkali, which I explained it to you, but there's a wonderful slide over here. So just a minute here. So there's a difference between alkalis and bases, what it is. So copper hydroxide is a base but not an alkali. So why? Why do I say it? It's because if I have copper hydroxide, okay, so CuOH twice. So folks, just a minute. I'm gonna again annotate on the screen. Just a minute. CuOH twice over here. It is a base. Why is it a base? Is because it has, basic properties. Now there are various basic properties, not just OH minus ions, but you don't have to remember it right now. That comes later on. Okay, so don't get confused. Just remember, keep it in mind that CuOH twice is a base, but it is not an alkali. Is because if I have a beaker like this and the beaker has water up to here, I take CuOH twice and put it in water. It is not going to dissolve. It is not going to be soluble. Okay, so that's why I say that CuOH twice is a base, but as it is not soluble in water, it is not an alkali. Okay. Now NaOH is a base, and if I throw it in water, it is soluble, it dissolves. So that's why I say that NaOH or sodium hydroxide over here is an alkali. Okay. And the statement I just put in the chat box is this: all alkalis are bases, but not all bases are alkalis. What it means is all bases do not dissolve in water. They are not soluble in water. Those which are known as alkalis. Okay, so this is a basic difference between what are bases and alkalis. You don't have to go in detail about this right now. You have to understand the difference between both of them. All right. Just a minute, the chat box is buzzing, so I'm gonna see. Suhas, I think you're a little confused. I don't know. So, folks, if you have any confusion, any queries you want to ask me, raise your hand. So when I'm teaching, just raise your hand. I'll just quickly clear it. I don't want any of you to go home. You're already home, but in the lecture. All right. So if you understood this, give me a yes. We also have a check later on at the end of the lecture, not right now. So yeah. All right. Thank you so much. Great. So I'm going to move ahead now with the chemical properties of alkalis. Okay. So what are the chemical properties? So how do you know? So folks, nothing but chemical properties are nothing but if I have a substance, okay, and I want to test what that substance is. So if I have a metal, for example, I'll just give you an example. If I have a metal and if I have a non-metal, for example, if I have a piece of iron and I have a piece of cotton, okay, cotton. Now I want to check the properties. So if I want to check the magnetic properties, what I do is I take a magnet and put it next to cotton. Cotton will not do anything, it won't react. But iron will be attracted to the magnet. So that means that magnet has strong magnetic, the iron has strong magnetic properties. Okay. So that is what it means. Similarly, chemical properties of a substance is nothing but how does it react with chemicals. Okay. So how does alkali react with chemical, and that is nothing but the property. To define how a substance works is nothing but chemical properties of alkali. Okay. So what are the chemical properties is nothing but first and foremost. Okay, instead of me reading this, I'm going to request someone to, because as much as I love hearing my own voice, I love hearing your voices as well. So let's say Shubham Ji, if you're there with us, just quickly read the first point on the screen. Isha, you can read the next point. Pratham, go after that, okay?
Alkalis have a bitter taste and soapy.
Absolutely. So some scientists, they were working on alkalis in their labs, and they saw that alkalis, if you taste it, I won't suggest anyone to taste it, okay? Just keep it in mind. Don't do this at all. So if you taste it, it's a bitter taste. Okay, so Karela kisne khaya hai? Karela. What is it called in Marathi? I don't know. Karla, I guess. Karla. So it is very bitter, right? So that is nothing but that taste alkali has. And soapy feel is nothing but when it's very slimy, soapy. Like if you touch an alkali, which I suggest you do not without gloves, but if you do touch it, it feels like it froths up. I said bubbles, as a soapy texture is uska, okay. So the next point is Aisha, go ahead, read it for us, please.
Alkalis turn red litmus to blue.
Yeah, absolutely. Alkalis turn red litmus to blue. So why is it so? Why do alkalis turn red litmus to blue? So it's very easy answer, folks. Just anybody just come off mute and tell me this. So why do alkali turn red litmus to blue color? You can also see it in the photo over here now. Image.
Yeah, can I?
Go ahead, Aditya.
Because alkalis are bases, so that's why.
Absolutely. See, alkalis are bases. That is why when you put it in red litmus paper, it turns blue. Basic, information. And the last part, who did I request? I guess Pratham, I requested you, right? Can you just read the last part for us?
Alkalis react with acids to form salt and water only.
Thank you so much. All right. So alkalis react with acids to form salt and water. So again, can anyone just tell me why does it happen? Why, if I put alkalis with acid, why do they form salt and water? This reaction has a name, folks. We actually were talking about
Neutralization.
absolutely neutralization. So acids, alkalis are nothing but bases. And if you put a base and an acid together, what is going to happen? They're going to cancel out each other. And nothing but neutralization happens. So what is neutralization? It's in the name to make it neutral. So being neutral is what we are looking forward to. And that is nothing but if you mix an alkali and an acid, what happens is that nothing but neutralization, we get salt and water. Okay. So there are basic now. These are some chemical reactions that you can look up to for examples. So I'm gonna request someone who hasn't shared in a wonderful class over here. So let's say Rutu, if you're there with us, can you just read both of these chemical equations for me? Rutu, if you're there.
NaOH plus HCl is equal to NaCl plus H2O.
Absolutely,
Second,
thank you. Second, yeah.
2KOH plus H2SO4 is equal to K2SO4 plus 2HO2.
Yeah,
H2.
H2O. Yeah, yeah. HO2 is different thing. So yeah. All right. Sodium hydroxide plus hydrochloric acid gives NaCl, which is nothing but common salt which we eat, plus H2O. And 2KOH is nothing but potassium hydroxide plus H2SO4 is sulfuric acid, gives us potassium sulfate plus water, which is nothing but H2O. So these both of these things, folks, NaCl and K2SO4, they're nothing but salts. All right. So they're nothing but salts, and this is what you get. You mix an alkali, you mix an acid, mix kar do. They neutralize each other, and you get nothing but salt and water. All right. Great. So if you've understood, chemical properties, I think you might have understood this, but it's up to you. So if you give me a thumbs up, if you have any queries about this, come off mute, raise your hand and come off mute so that if multiple people, want to ask something, I can give them a chance. All right. Great. So I'm seeing that you're giving me thumbs up, so I'm going to go ahead, folks. There's something in the chat box. Okay, yes. All right. All right. So we don't have chemical properties of alkalis right now, but I'm going to be starting with uses of base. So basically, before I go there, I'm going to show you some common alkalis. Some common alkalis that you find in your life. You might have heard about it somewhere, or you might have seen them somewhere. But always, concept is important, people. But you have to put an image, put a name to that concept. So that is nothing but giving examples. So some common alkalis are nothing but, first and foremost, सबसे important, put it in your mind, is NaOH. All right, sodium hydroxide, सबसे common alkali you will ever hear about. Okay. Second is potassium hydroxide, again very common. Third is calcium hydroxide, CaOH twice. All right. And the last is nothing but ammonium hydroxide, which is NH3 aqueous, and you can find ammonia in your urine. Okay, so yeah, that smell of urine you get, it's because of ammonia. Okay, and the greater the ammonia, the bad, like the worse it is. Okay, so that's why people tell you to drink more water. So that's the reason behind it, and it's a biological reason. I'm not going to get into the biology of it, but yeah. So these are some common alkalis we have. And folks, basically, I got a suggestion yesterday that when I ask you to take screenshots of these PPTs, it's pretty fast. So what I'm going to do is after this lecture is over, I'm going to send this PPT on the group. So anyone of you can refer to it. Okay, you don't need to take screenshots for it. All right. Great. So I'm going to now give you uses of bases. There are certain small uses of bases. So these are 4 points. Quickly, someone come off mute who hasn't spoken. So wait, no, Viraj, if you are there, just quickly come off mute and read these 4 points for us quickly. The uses of bases.
Sodium hydroxide and potassium hydroxide are used in making soaps. Ammonia solution is used in window cleaners. Magnesium hydroxide is used in toothpaste to neutralize the acid produced by bacteria. Calcium hydroxide scaled lime is used to neutralize acid found in acidic soil.
Absolutely. Thank you so much, Viraj. So people, it's actually slaked lime. Okay, slaked lime. So calcium hydroxide. So there are many uses of these alkalis and bases. Actually, it's all around you. You just don't know that they are there. Okay, they are all around you. So you might ever wonder, ki, Bhaiya, why are we learning all of this? Is because you have to understand the world around you, and these things are pretty basic. You just have to know about them. It's very important to know. Okay. So yeah. So folks, we have done with first part is water, alkalis, and the differences between alkalis and bases. So now, before I go to the next topic, which I'm going to be teaching you all, I'm going to be showing you a video about pH levels. And it's a wonderful video, all right? So I'm going to send this link on the chat box, all right? And this video is just hold on a sec. I'm going to load it on my PC as well. So okay, wait a minute. So my request to you is that there are two options which you can do. Is first of all, you can go to the link directly and from your YouTube on your phone, you can look at that. Or what you can do is nothing but you can watch it with me on my screen. Okay. So whatever is good for you, because some of what happens is that some of you, your screen gets jittery and everything. So yeah, so I just thought it would be better for us to do it that way. All right. So just a minute, hold on a sec. I'm gonna give you the link right now. It's a 3-minute video. I'm gonna give you 5 minutes for it so that there is certain lag beach mein here and there. So just a minute. The link is sent in the chat box. Just open it and check it if it's the same link. Yeah, wonderful. Yeah, it is the same link. So folks, two options. 12:55, 1 o'clock we come back. Either watch the video or watch it with me because I'm going to be sharing my screen. Okay. So I hope all of you watched that video and you are pretty clear as to what happened. If you're not, so obviously I'm going to discuss it over. So don't worry. So what was that video about? Can anyone tell me, was understood it and, got something out of it? Can just anyone come off mute? Yes, Shubham, you have raised your hand. Rather, you can go after him. Okay. Go ahead.
I understand that between 1 to 6, the pH level the pH level between 1 to 6 is called acid, and between 8 to 14 is called base.
Absolutely. Any more points that you have understood from the video or something you have taken, If not, then rather you can go ahead and share it with our classroom.
Bhaiya, there was a great scientist who invented a pH scale. I just forgot his name, but he invented a pH scale, and the pH scale is between 0 to 14. And from 0 to 6 and 7, we can eat or drink the acid recipe. But from 8 to 14, it is dangerous to take because from there it becomes bases. And this and our body also has a pH level. So that's all that I understood.
Oh God, that is amazing. That is you understood most of those things. Okay, so yeah, great. Pratham is also raising his hand, so Pratham, go ahead, share it with us. What do you think about the video and everything?
Hi, yes. The acids means the lower the number, the more acidic and the more harmful it gets. And the same thing happens with the bases, but instead, the higher the number goes, the more basic and harmful it becomes.
Absolutely. So people, you have got the basic idea of what I'm going to be teaching you. Okay. So just a minute, I'm going to be again sharing my screen with all of you. Okay. Why so? Is to make you understand pH level. So you have a basic understanding of what a pH level is, pH scale is, sort of on the level what a scale is. So if you can see my screen, give me a yes in the chat box because I'm sharing. Okay. So this Sorensen guy, what he did was he wanted to understand if there is a way to to see to it that we can differentiate acids and bases, and he did a wonderful job. So how did he do it? It's nothing but he made a simple scale 0 to 14. All right, 0 to 14. In the middle is from 0 to 14, obviously 7 is the middle, right? 7 is the middle number. So our water, what we drink, is nothing but it is neutral. The pH value is neutral. So what is pH value? I'll start from there now. All right, so what is pH level? pH level kya? So pH. P stands for potens, H stands for hydrogen. So it's a German word, potens, hydrogen. Basically what it means is you can remember potens as potency or power. You can remember it as power. So power of hydrogen. So basically how many hydrogen ions, H plus ions are there in that solution. That is nothing but the pH level. Okay. Power of hydrogen, potens hydrogen. Potency, number of hydrogen H plus ions are there in the solution makes the pH scale. All right. So now now this is a little ulta, but you have to keep it in mind. The more the H plus ion concentration means, the more H plus ions are there in the solution, the lower the pH value is going to be. So if H plus ions are more, it means that the substance is acidic, and that means that its pH level, pH number will be smaller. So pH number will be smaller and acidity will be higher if there are more H plus ions. Getting me? If you're getting this, give me a yes, or raise your hand, whatever. More the H plus ions, more the concentration of H plus ions, more the acidity, lower the pH value. Okay. So more acidic is chota number. The lesser the number is, the more it is acidic. Inversely proportional. Okay. Great. So the next is abhi for base. What it will be for base, right? Base ke liye exactly opposite of what I just told you. Just a minute. Yeah. So for base, it's going to be different. For base is that as H plus ions decrease in a solution, so let's say H plus ions, they are decreasing in the solution. That means the acidity of the solution has reduced. Acidity is less because H plus ions are less, so acidity is less. So as acidity is less, the solution is more basic. So basicity increases. And obviously as acidity has reduced, pH number ka kya hoga? pH number will increase. All right. So more the H plus ions, lesser the pH number, more the acidity. Lesser the H plus ions, more the basicity, lesser is the acidity, more is the pH number. So jitni number of pH H plus ions is inversely proportional is the pH number. All right. So this is a basic scale this guy used to dictate or to show the world how you can choose what are different pH levels. Okay, or what is the potency or what is the power or the concentration of the acidity. Now, folks, if an acid has a greater pH level, so let's say if it has on both extremes, okay, so from 0 to 3 or from 14 to 11, this range is very dangerous for us, both of them. So 0 to 3 is very, very dangerous. So if you put it on the skin is going to melt. So 0.5 pH value ka agar HCl dala, the skin will directly melt. Okay. And for alkalis, your skin will corrode. It's a different word. So corrosion, if you want to read it about it. Both are very harmful because water is at the middle. This is where human body is. It's around 7.35 to 7.45 pH human body. And yeah. So when you say कि मुझे acidity हुई है, it means that your pH level in your body is in imbalance. And that's why acidity increases. That's why you drink something known as ENO. ENO पता है क्या पिया होगा? ENO or Jaljeera, I guess.
Yes.
You drink it to make you feel better. It's nothing but a basic solution. So if you have acidity, you drink that. It is a base. So if acid and base they mix together, what happens? Neutralization, right? So that is why we use the ENO or something like that. Okay. So this is nothing but the basic pH scale. And what is the use of this scale is nothing but how is it used now? So you might be thinking, Bhaiya, how is it used? Is nothing but, for example, let's say we have a beaker like this, all right? And there's a solution, any solution. I don't know the pH level. So what I do is, either I put a litmus paper and check if it's a base or acid. So with a litmus paper test, people, what we can do, we can judge if it is an acid or a base, but we can't tell how how potent it is. So to know that, there is something known as a universal indicator. So what a universal indicator is that it not just only measures, okay, it not just only measures the solution, it measures it for both acids and base. So for example, I have this indicator, and indicator is nothing but it's a solution, it's a liquid hota hai. We put that liquid in our solution. So depending on how the liquid changes color, okay, so the liquid can be of, it can be neutral, so it can be colorless or it can be with color. So let's, for example, take it is colorless. So if you put in water, the color you will get is this 7 number ka jo color hai na. But tell me what will happen if you get red color. If I put this in the solution and the solution turns red, if I put universal indicator as drops mein the solution and the solution turns red, so what will it be? It will be an acid with pH level between 0 and 1. So we have also come to know the pH level. So let's say I have a hand soap over here, hand soap, and I create a solution, put the universal indicator. The universal indicator changes from transparent to green in color. So I'll say it is a hand soap, and the pH value is 10. So you understood? So pH value tells us, sorry, the universal indicator, it tells us if it is acidic or basic, and also how potent it is. What is the pH value? All right. So this is how basically we use pH indicators and pH values to understand basically. So what is, what we are working with and how does it affect us. All right. So this is nothing but the basic thing. Now just